problem. See the next one. Next we have to find here scalar potential phi. Okay, so for observe here scalar potential, that is nothing but scalar function only. Okay, so for finding the scalar potential we are going to apply here one condition, that is vector f is equals to del phi. Next we have to find a scalar potential, that is nothing but phi only. For that one we have to consider this condition. Okay, what is that? Del phi is equals to vector f. In a previous problem they mentioned this condition, but in present problem they are not. Therefore here consider this one. You have to remember this condition for finding the scalar function or a scalar potential. What is that condition? Del phi is equals to vector f. Okay, so you know that del phi it is nothing but a gradient of a phi. So what is that definition? Dou phi by dou x into I plus dou phi by dou I into j plus dou phi by dou I into dou z into vector k, that is equals to vector f. Okay, so that vector f is nothing but, you know that is the given here. What is that vector f? This is the vector f. Okay, right here 2xy square plus yz into vector I plus 2x square y plus xz plus 2yz square into vector j plus 2y square z plus xy into vector k. This is the given vector f. Okay, so observe here LHS and RHS part. This is also vector, this is also vector. We are going to find here scalar potential phi. Okay, by equating on both sides of the coefficients of I, j, k. So coefficients of I. What it implies? What we have? Coefficient of I on LHS dou phi by dou x. Coefficient of I on RHS 2xy square plus yz. 2xy square plus yz. We are going to find here phi. But what we have here? Partial differential term. We have to remove here dou by dou x. We have to remove here dou by dou x. Then we have to integrate on both sides with respect to x. So integrating on both sides with respect to x. So what it implies? Integration of a differential term implies a function phi is equals to. Then integration of a 2xy square plus yz with respect to x plus. Here also same case. As I explained in a previous problem, we have to consider an integral constant as an arbitrary function. Arbitrary function, it is nothing but f1 of y comma z. Because we are going to integrating with respect to x, then we have to consider yz as a constant. Therefore arbitrary function in terms of yz only. So this arbitrary function acts as a here integral constant to this term. Then phi is equals to, find here integration. So y square is a constant, 2 is a constant. Take it outside, 2y square. Okay, keep it as it is. Then x with respect to x, what it implies? X square by 2 plus yz is a constant. Take it outside. Integration of a dx. So x. Integration of a dx, x plus f1 of y comma z, keep it as it is. Then phi is equals to 2 to get cancels here. What it implies? X square y square plus yz, x can be written as x yz plus f1 of y comma z. Consider this one as equation 1. Then say here also same here. By equating the coefficients of a j. Okay, so what we have? A coefficient of a j, dou phi by dou y is equals to coefficient of a j on RHS 2x square y plus xz plus 2yz square. 2yz square. This is our coefficient of a j on a RHS side. By equating the coefficient of a j on a both side, you will get dou phi by dou y is equals to this one term. Then we have to remove here dou by dou y. Yes, by removing a dou by dou y, we have to integrating on a both side with respect to y only. Okay, so integrating on a both side with respect to y, because our differential term, partial differential term dou by dou y, we have to remove this one. Therefore, we need to integrating with respect to y only. Then integration of a differentiation term means this phi as it is. Then integration of 2x square y plus xz plus 2yz square with respect to y plus, consider here integral constant means arbitrary function as a means arbitrary function in terms of a x and z, x comma z. So this arbitrary function acts as a here integral constant. Then phi is equals to 2x square is a constant. We are going to integrating with respect to y. 2x square is a constant. Keep it as it is. Integration of a y with respect to y square by 2 plus x, z both are a constant. Keep it as it is. Integration of a dy, y only, plus 2 z square is a constant. Keep it as it is. Okay. Y with respect to y. What it implies? Y square by 2 plus integral constant means arbitrary function. Keep it as it is. Then phi is equals to 2 to get cancels. Here also 2 to get cancels. So what it implies? X square y square. X zy can be written as x y z plus z square y square or y square z square, both are same, plus f2 of x comma z. Keep it as it is. Consider this one as equation 2. Then in the next case, we are going to equate the coefficients of a k on a both side. Coefficient of a k. Okay, so what we have a coefficient of a k on LHS side, dou phi by dou z. This is a z. Okay, so dou phi by dou z is equals to. Then what we have a coefficient of a k, 2y square z plus xy. Right here. 2y square z plus xy. Then here also same case, we are going to remove here dou by dou z. Then we need to apply here integration, that integration with respect to z. So integrating on a both side with respect to z only, with respect to z. Then integration of a differentiation term, then it implies function, that phi. Then integration of 2y square z, integration of a 2y square z plus xy with respect to z plus, consider here arbitrary function f3 in terms of x and y, because integration with respect to z, x and y acts as here constant. So the f3 in terms of xy, arbitrary function in terms of xy, this acts as here integral constant. Then phi is equals to, observe here 2y square is a constant. Take it outside from the integral sign. 2y square, take it outside. Z with respect to z, what it implies? Z square by 2 plus xy, both are a constant. Keep it as it is. Integration of a dz, z plus f3 of x comma y. Then what it implies? Phi is equals to 2 to get cancels here. Then y square z square. Okay. After 2 here, y square z square plus x y z, okay, plus f3 of x comma y. Consider this one as equation